So welcome to another section of the AT Library tutorial series. This tutorial is going to focus on introduction to statistics. Actually, we have some tutorials that cover how you can go about your research, and we know that in research it deals with data, and you have to analyze your data using any of these statistical applications. We have a lot, but this tutorial is going to focus on Stata, SPSS, and R. And we just introduced this section on our YouTube channel in June, actually this month. So this is just an introductory video to data analytics using Stata, SPSS, and R. Actually, before you can use these software, that is the Stata, SPSS, and R, to analyze your data, you should understand the concept of statistics. You should know what actually you are doing with your data, and you should understand, or you should know, the interpretation of your data. So this is just an intro, but as we move on, we are going to combine this. We have descriptive statistics, we have inferential statistics, but we will be moving deeper, and we will be introducing some dummy data. We'll be analyzing this data with this software that is stated over here. Then we will take you through how you can interpret your results. Yes, so after running your analysis or after analyzing your data, how that is the interpretation, Z-score, t-test, a whole lot. We will be dealing with hypothesis. So we have a lot of goodies for you. Just subscribe to the channel, okay? Now, let's start with something. What we have over here, that is, we have, so we move to the next slide. We have, let's start with an example with the introduction to statistics. So have you ever wondered why people eat fast food? Hi, so yeah. Have you? Just take some seconds and ask yourself that question. Have you ever wondered why people eat fast food? So you see the image over here? Sure. Now, well, statisticians use surveys and questionnaires to ask people about their fast food habits. Assuming that we are going about this. So what we are trying to say is that statisticians do use surveys and questionnaires in order to get insight to any other thing. They use surveys and questionnaires to ask people about their fast food habits. But here's the thing. Sometimes people might not give honest answers, or they might not even know why they eat fast food themselves. So it can be tricky to get a real answers. Basically, this is telling us that if you really want to know why people behave in a different direction, there's a need to send questionnaires out. Is probably maybe an interview guide, or you are going to ask people why they engage in this particular habit. And that is what statisticians mostly do. Now, even when we have survey results, so let's say we went out, we took a survey, even if after getting a survey result, they might not tell us exactly what we want to know. Yes. Why? Because some people might give us some information related to our question, but not the whole picture. So we can say that this type of information is known as the proxy. For example, if you want to know if people eat more fast food on weekends, we not only need to know how much fast food they eat, sure, but also on which days they eat it. You have to know these two things. Also, if you want to know if eating fast food causes stress, we need to measure both the fast food consumption and the level of stress. This is all what statistics is about. Now, then let's ask ourselves, what is statistics? Statistics help us make sense of all these data. So if you want to make sense out of your data, then statistics do come in. It helps us filter and understand the information around us. However, we need to use statistics carefully and know their limitations. Sure, they can't answer all questions, and sometimes the answers might have some uncertainty. That is not certain 100%. It's up to us to make decisions based on the information we have, even if there is some uncertainty involved. So basically, we are saying that statistics can be really helpful in many different areas of life. It can help us understand trends, make predictions, and make informed decisions. That is all what statistics is about. Now, what are the types of statistics? We are going to deal with the two main types of statistics, but actually this tutorial will focus on descriptive statistics. Then in our subsequent tutorial, we move on to inferential. Then we pick one after the other what after the descriptive statistics, what goes under descriptive statistics, we'll move on to inferential statistics. We'll discuss what goes under inferential statistics. We run data on all these inferential descriptive using this software that we mentioned earlier on, that is the Stata, the SPSS, and the R. So there are two main types of statistics. That is, we have the descriptive and the what? Inferential. Now, what is descriptive statistics? Descriptive statistics is all about summarizing and describing data in a meaningful way. So you have your data, you just give a summary. Yes, thousands of data, millions. So with descriptive statistics, it's all about summarizing your data and describing your data in a meaningful way, making it presentable. It helps us organize and understand the information we have. Now, here's how descriptive statistics can help you. We are going to focus on some areas that involves descriptive statistics. In every data, we have the mean. Now, what is mean? The mean is also known as the average. Let's imagine we have a class of 10 students. Yes, and each student receives a mark out of 10 for a test. So the total marks for the test is supposed to be up to 10. Now, to find the average mark, we add up all the marks that each student got and then divide that total by the number of students. For example, if the student marks are 8, 6, 9, 7, 5, 8, 7, 6, 8, and 9, we would add all these numbers together. So we have 8, 6, 9, 7, 5, 8, 7, 6, 8, 9 equals to 73. All right, so that is the total. Now, if you want to find the mean, we are saying that we divide the total by the number of students. So that is the total over here, 73, which is, so we divide the total by the number of students, which is 10. So 10 is the total number of students in this case. So 73 divided by 10 is equal to 7.3. Now, what is the interpretation of the mean? What is the interpretation? Therefore, the average mark for this test in the class is 7.3. And so it means what? This means that on average, the students in the class scored around 7.3 marks out of 10. That is the average mark. It gives us an idea of how well the whole class did overall. Sure. So averagely, a student scored what? 7.3. That is the interpretation of what? Mean. Move on to the next one. Let's discuss the median. Imagine you have a group of friends and you want to know how tall everyone is. To find out, you can line up all your friends from shortest to tallest. Now, look at something. The median is the person who stands right in the middle of this line. So after arranging your friends from shortest to tallest, the median is the person who stands right in the middle of this line. For example, let's say you have another group of friends and their heights are 90 centimeters, 95 centimeters, 100 centimeters, 110 centimeters, and 200 centimeters. In this case, the tallest friend is much taller than everyone else. Sure. If we only look at the tallest friend, we might think that everyone in the group is really tall, which isn't the case, you know that? But by finding the median, we can see that most of the friends are around 100 centimeters, which is more typical or normal. So, what is the interpretation when it comes to the median? So the median tells us about the typical height because it's not influenced by the one really tall or really short friend. It helps us focus on the height that most of our friends have, giving us a better idea of what is normal or typical in the group. That is the median. It gives us a clear picture as what you see over here. So it focuses on the height that most of the friends have. All right, good. So that is the median. Now we move on to the next one. We have the mode. Here's how descriptive statistics can help you understand the mode. Imagine you have a bag of colorful candies and you want to know which color appears the most. The mode is the color that shows up the most in the bag. Let's say you have 10 candies in your bag and their colors are red, blue, red, green, yellow, red, blue, blue, yellow, and green. If you count the colors and see which one appears the most, you find that the color red appears 3 times, more than any other color. Well, so in this case, the mode is red. Now, the mode helps us understand what is the most common or popular thing in a group. It's like finding the winner in a contest or the most liked candy flavor. The mode can also help us make decisions. So these are the interpretations of what the mode. Example, let's say you and your friends are trying to decide which game to play. And you have 3 options: chess, soccer, and hide and seek. If most of your friends prefer playing soccer, then soccer is the mode. Why? It's because most of your friends prefer playing with soccer. And you know that is the most popular choice among everyone. So that is the interpretation for the mode. Now, our last one is what? The range. And what is it about the range? Let's see how descriptive statistics can help you understand the range. Imagine you have a collection of different size toys, and you want to know how much they differ in size. The range helps us understand how much the size of the toys vary. Sure. So let's say you have 5 toys, and their sizes are 10 centimeters, 12 centimeters, 8 centimeters, 15 centimeters, and 7 centimeters. To find the range, we subtract the smallest size from the largest size. In this case, the smallest size is 7 centimeters, and the largest size is 15 centimeters. So if we subtract 7 from 15, we get a range of 8 centimeters. What is the interpretation of this? Actually, in statistics, interpretation is key. Understanding the concept is key. Now, the range tells us how spread out or different the size of the toys are from one another. It shows us the total amount of difference in size. For example, let's say you have another collection of toys and their sizes are 5 centimeters, 6 centimeters, 5 centimeters, 7 centimeters, and 6 centimeters. In this case, the smallest size is 5 centimeters and the largest size is 7 centimeters. If you subtract 5 from 7, we get a range of what? 2 centimeters. This means that the sizes of these toys are not very different from one another. They are very close. They are very close in size, and the range is what? Small. Well, this is just a short tutorial when it comes to descriptive statistics. We will end here for this particular tutorial. In our next tutorial, we'll move on to inferential statistics, but we'll do more about the descriptive statistics before we move on to the inferential statistics. You need to grab this information. You need to really understand this before you move on to using these applications, the software to analyze your data. All right. Remember to subscribe to, A2 Library Tutorial has a lot of videos for you. So remember to subscribe to our channel. Just click on subscribe after watching this video. Thanks very much.